Hello and welcome to another Solana tutorial. Today we're gonna have a look at another token extension, namely token groups. Because I never did a deep dive on that, and yes, this is a deep dive, meaning we're not just gonna have a look at what it can do and how you use it, but of course we're also gonna look at how the stuff is stored on chain and what instructions you actually need to call to do it yourself if you wanted to do it with a kit or with Rust. But I think we're just gonna do the kit here in this video, and then and you just do it in Rust and it's gonna be the same, right? So yeah, that's all the context that I need to give for this. Let's have a look. I want to start with docs. Tokens on Solana, extensions. So if you haven't watched any of my videos, when we're talking about token extensions, we're talking about a specific token program, the new token program, Token Z, or also called Token 2022. And that thing has a bunch of extensions. For instance, the token group, and then also the group pointer, which, like token metadata and metadata pointer, somehow belong together. And all of those actually, group member pointer as well, and token group member, so many things. All of those actually belong together a bit. We did have a look at metadata pointer and token metadata in the previous video, and now I want to better understand the groups. But let's first do a higher level overview. Some extensions have their own docs like metadata and metadata pointer, but I think groups does not have that privilege. Well, then we do without docs, that's fine. Well, but then let's at least read what the comments in the source code say. That's as good as docs that we will get. Mint containing a pointer to another account or the same account that holds group configuration. So group pointer points to some kind of configuration. That's probably the metadata of the group. Then the token group, Mint contains token group configurations. So token group means we store the configuration, so basically the group metadata, in this Mint. So that's the same as this for the metadata pointer. The token metadata, if we have it on that Mint account, means that this Mint account stores metadata in the extensions of the Mint account. And if it has the token group extension, then it stores the metadata for the token group in the Mint account. And then there's group member. I'm glad I look at this because I've never worked with this, and it could be good to know if you want to do native collections. Who still does collections? Was that just an NFT thing and NFTs are basically dead? Well, are they though? No, just the hype around them might be dead or dying. At least that's what the floor prices of my NFTs are saying. But that doesn't mean that there are no use cases for extra NFTs. Like, those tokens were invented before we made them memes. Anyway, so group pointer is pointing to a Mint that has the token group extension and holds the actual information. And then we have group member. So that is then the thing that is part of a group. Mint contains a pointer to another account or the same account that holds group member configuration. So that then just says I am a member of some group, and of what group is specified in yet another extension. So yeah, that might seem very confusing in the beginning. I mean, it does to me. Why do I need two here? I mean, that we have two here, that makes sense. Okay, so one Mint storing the data and then the group pointing to it, such that we can do the same thing of just storing the info once and then have several groups with the same configuration, but still being different groups. Like we had here, different tokens that all point to the same metadata. But why we need two things for the member? A member should just point to a group, no? Why do I need two things for this? What else is being stored here in the token group member thing that I need an extra extension for that? I don't know, but I will find out for all of us. So let's have an actual look at token groups. Do we first read source code, or first probably we want to start with just trying it out and then we get the understanding of what we actually just did? How about that? Just give me a console. I'm just gonna get myself an authority and we're gonna test on DevNet, and I need some sol. And then with the setup, let's create a token with a token group. So Solana keygen grind. I just like to use addresses that make sense to me such that I can properly talk about them. So my token 1 is a token. This is just gonna be my first token. And then I need a token that contains the group config. So a token with group config, a TGC. This might be too much. Nope. The TGC1, there we go, the first group configuration. And let's create those two tokens. Just checking if the CLI is obvious enough what I need to do here. So we're gonna do this with SPL token, create a token. I'm just gonna for myself enable, and then I'll need help. Yeah, enable close and enable metadata, enable group. Enables group configuration in this mint. And the mint authority must initialize the group. So it's pretty much the exact same as with the metadata, just that we're now talking about group configuration. And my question is, do we need then also metadata within the group? Not sure, because then the token itself. So basically, because I implicitly understand this, I just want to make it explicit for you. We are creating a token that holds the information for the group. And then we create the tokens that are actually part of the group. But the group itself is represented by a token, because we got to write it somewhere. The easiest way, if we just use the token program, is, well, to create another token mint. And that mint can also have metadata. It's just another extension. But for now, we will just let it be the group. We enable group. Then we need to say we need the program 2022. And then I want this to use the token group configuration mint. Anything else I need? I don't think so. Okay. And then it again neatly tells me to initialize group configuration inside the mint, please run SPL token initialize group. Before we do that though, let's check the account. So Solana account, check this. There we go. We have an authority. Interesting, my authority has a 0 at the very end. Hold on. That's a funny coincidence. If we checked it with the script from a previous video, we see that yes, actually this address, this pub key, has a 0 at the very end. Funny. But anyway, I'm getting distracted easily. So that's the mint authority. All of that is just the regular token stuff. Here we have initialized, here we have 9 decimals. That's a bunch of zeros because we have no freeze authority and whatever. And then here come the extensions. So here start the extensions. And we also know from last time, this means that it's a mint. So that's just what token 2022 accounts need, an additional byte for telling you if it's a mint or a token account. And then we have extension number 3, which has 32 bytes, which are those. And extension number 3 is probably the close. And then that's the close authority. And then 14, like 1-4, so that's extension number 20. That is probably the group config. Yes, that would make sense because the last time we looked at it, it was 19 and now it's 20. So that's the next one. And it stores 2 things, the authority, I guess, and then the mint itself again, probably, most likely. Here, that's authority and mint. And then there is no extension yet for the actual group config, because that we still need to add with this command. I'm just gonna copy it. Max size. What is that? Give me the docs for this. You initialize group extension on a token mint. Yeah. The number of members in the group. Okay, so it's not about like bytes or anything or in the token account. No, it just says there is a limit for how many members this group can have. Interesting. And maybe that config also tracks how many members there are. That would make sense. Again, we're just slowly figuring out what the features of that are because I have no idea. And a token mint address is an argument that makes sense. We need to have that mint on which we want to initialize the group on. So, okay, so then let's do it. And I'm gonna say my max member size is 2 because we're testing and I want to be able to reach that maximum. Okay, so far so good. That didn't really show me much, but I can check the account again. And now all of a sudden there is more, because last time we looked at here the extension number 20 with 64 bytes, namely the authority and the mint. And then we have oh, guess what? Extension number 21 with 5 zeros, so that's 64 plus another 16. So I would guess 2 U64s, because what else is 16 bytes? By the way, these are all hex numbers. That's why it might be confusing. It says 50, but that's 64 plus 16 because we're talking hex. If you don't know what hex is, maybe you want to watch my video on encodings. Good old times. Or just Google it. Or let the AI of your choice explain it to you. What a world we live in. Okay, anyway. So we have 50. Now I also say 50. We have 64 plus 16, which is how much? 80 bytes. The first 32 is again my address, my pub key, so the authority for the group config, and then again the token mint, and then look at that, numbers. I would guess 1, 2, 3, 4, 1, 2, 3, 4. This is a number, probably the amount of active members in this group, and then this is a number, 8 bytes, the maximum amount of members in the group, which we set to 2. So not surprisingly, here's a 2. And that's all just my assumptions on what that actually is, because I look at the account and I make educated guesses, because I can recognize patterns, namely those of my address and those of the mint. Then I just guess the rest. This, by the way, is also how I would reverse engineer programs if I don't know what they do, but I can look at their accounts, then I can be like, maybe that's that, manually deserializing it or trying to deserialize it. That's a skill, and I like to practice it sometimes. That's why I like doing this. But we can prove that it's actually what we think it is by either looking at the Explorer or the source code. Maybe let's start with the Explorer. What would the Explorer tell me? If I checked this account on here, you would tell me we have the 3 extensions, mint close authority, group pointer, and token group, which have no description, but at least the Explorer can figure them out. And if I click on them, then they will tell me the group pointer has the token group, which is the mint, pointing to a mint, which can be itself again, but it can also point somewhere else because it's a pointer. We saw that at the metadata pointer, that the pointer can also point to a different mint. In this case, we're pointing to ourselves, and then the group pointer authority is my authority address, so my signer. So far, so good. And then we have the token group extension, which again has the mint, could apparently reference another token mint, must not necessarily be the mint itself. Then again, the update authority, so that's a required signer for changing this extension or things in the extension. Maybe I can change the max size. I don't know, maybe. And my guesses were correct. We do have the current size and we have the max size. I would like to see this in source code as well, though, just to practice where we see those things. Because that might not even be in the right order. Is it in the right order? Is it in that order? On the account, it is first the update authority and then the mint. But here it says first the mint and then the update authority. So, the Explorer is great for showing me the details, but for actually working with the state, like working with the account, it's better to look at the source code, like how the things are lined out. So let's do look at the source code, just because I want to. We have Solana program token 2022. The program source code has extensions, and here we have the group member pointer and the group pointer. We started with a group pointer, so we're not talking about members yet. We're just establishing what is the group. And this thing, let's check. That's how the process instruction is. There's an initialize and an update. The update, the initialize does what we just said. It writes the authority and the group address, group pointer. Where is the state definition of this though? In extensions, group pointer, group pointer. So maybe that's not in here. Maybe there's a, where is that? You know what? I'm gonna open it here. Oh, probably in the interface. We were looking at the program here, but the group definition is in the interface, yes, as in interface. So that would be in interface, extension, group pointer, mod. That's what we opened here. That should be the same thing. Yeah, it's the same thing. Cool. And basically, we just see what we saw already. There's the authority, which is an optional non-zero pub key. And that type is interesting because basically we're saying it is a pub key unless it's 0. So unless it's the system program address. And if it's the system program address, then that means the option is none. So there's no pub key present. Is that also what it says here? A pub key that encodes none as 0. Why do we do that? To save bytes and still support it being an optional authority. So we still support having no authority, because the authority can never be the system program itself, because the system program can't sign and it wouldn't use a PDA. It just doesn't, right? That doesn't make sense. The authority can be another PDA, can be another pub key, but it's not the system program itself. And therefore, we can have this optional non-zero pub key, which, by the way, if we are very strict and learned what we learned in one of the previous videos, it's not actually a pub key but an address. This should be an optional non-zero address. Here it says it group address. This name is still, we've been there. We discussed that this is not the right naming for it. It's an optional non-zero address. But anyway, we're not gonna go deeper here. We just say, okay, there's this 32 bytes that if 0 means that it's not present. Same for the group address itself. If it's all zeros, the group doesn't exist, or we don't have a group, or the group was removed, or whatever. And otherwise it points to the mint holding the group information, the group config. So that's the pointer. And then there's the token group itself. So that's what contains the information then. And here it basically just defines its type. It implements its type for token group and token group member. That's not very helpful. I thought token group also has like something stored. Then in the implementation, token group, what do we find here? Processor, what do we find here? Process initialize. With group configurations must have the group pointer extension initialized. Interesting. So you can't have just group configurations without having a group pointer as well. There is an update group max size, so we can also update that. And we check the update authority and group update max size. The group is a token group from state. From that we get the extension token group, and then we have this. That's so cool. I like this implementation. Looks really nice. But this token group, oh, here it is. How did I find that? In the state. State of what? Token group interface. There's a separate crate for it now. I see. Okay. Because everything is its own crate now as well. So also that is in a different crate. Awesome. Where exactly does that live in source code then? I'm not sure. But the downloaded stuff, like the dependency that it downloaded here, also gives me the source code. So I'm fine with that, because here I can see the important stuff that I'm interested in for the state of the token group. We also know what this is. Ah, so cool. SPL discriminate. There's the update authority. Again, an optional non-zero address. There's the mint, the associated mint, used to counter spoofing to be sure that groups belongs to that particular mint. Interesting. Here we see interesting information as well. The associated mint used to counter spoofing to be sure that groups belong to a particular mint. I'm reading that and I'm not really understanding it yet. The other two things make perfect sense. How many group members do we have and what's the maximum group members that we allow? That's just 2 U64s. Used to counter spoofing to be sure that group belongs to a particular mint. So what could go wrong? Somebody could just say, hey, my mint belongs to that group. But then, in order to be added to that group, maybe you need to sign with the token group token as well. So basically, you gotta have the authority of that mint? No, that doesn't make sense. What exactly does that mean? Why does the token group have an associated mint? The mint, it just points to itself in the normal case, right? So we're not even talking about adding a new mint or adding a member. We're really just talking about making sure that nobody else creates a mint. Now, I still don't get it. We probably will understand this at some point during this video. For now, it's still not sure. I mean, okay, we store the mint as well, but now we stored the mint like 3 times, 2 times in our account. I'm sure it makes sense. And they argue that it does make sense. I just need to understand it, which for now I don't. And that's okay. Moving on. So yeah, we stored the mint here once. And then we stored the mint here again. So twice we have the mint already in here. So it's quite bloated extensions, but you know, that's how they work. They need this information for security. But okay, maybe we'll understand once we continue. And we shall continue by adding actual tokens to the group. Yes. Note also the group itself does not store any information in terms of metadata. What's the group name, or what's the group symbol, or what's the group URI. But guess what you can do? You can add metadata to that token, and thereby basically you add metadata to the group, because the token represents a group, and therefore the token metadata represents the group metadata. At least that's how I would understand this. And also that's how Metaplex did it, so I'm pretty sure that Token 2022 does the same. So let's create another token, and this time we enable member. So that means that this token is part of a group. The Mint Authority must initialize the member. Okay, let's do it. Again, I will have enable close, and I will enable member with Token 2022. And I already have a mint. The token 1 is a token. Token 1 is token. Okay, check that account, and we will see the usual blah blah, the close stuff extension with authority, and then extension 1.6, so that's 21, right? 16 plus 6, no, it's 22. Wait, yeah, because 21 was the token group, so 22, we can also check that. So token metadata was 19, group pointer was 20, token group was 21, and group member is 22. So we're talking about the group member extension here with, again, twice 32 bytes. So that's the authority, and that's again the mint. Nothing unexpected here. So who can change it, and which mint are we talking about? It's so weird that you always have to store that. There must be a better way for this, no? But that's how it's done, so we just accept that that's how it's done. And then we will also need to initialize the group member pointer such that it then actually points to a group. Did it also tell me? Yeah, it also told me that I should use SBL token initialize member to actually add the group member pointer, and I need to sign with the Mint Authority and the group's update authority, because the group will need to be updated because we add a member. Luckily for us, we have the same authority as our Mint Authority and the group's update authority, because we just use this one key pair here. So we can just do this. SBL token initialize member. Does it need anything else? Probably. It will need the group token address. Oh yeah, that makes sense. So you can have the token group config token address. And then you probably have more info in your account again. So after extension number 21, where was it? So many bytes here. Extension 21, there was that with that and that. Comes extension number 22, who would have guessed? Which has 48 again. Ah, that's not correct. That's 64 plus 8, which is 72 bytes. So it's just, let me guess, authority, the mint again for whatever reason, and one number, maybe the how manyth it is in the collection. Would that make sense? What else would you store? What's my guess? Do you have a better guess? I don't have a better guess. Maybe they're also like sorted in the group. They have an order. It would make sense. Interestingly, now first comes the mint, but then comes something new. Hold on, wait, no, that's not the mint. Just because it starts with 6, hold on. Those are two different things now. Here, once again, we had the 620F. Here we have the 620F. But then we have again a 6 to 90, and that I think was the mint. So this and this might not be the mint. Let's check the other account again. Where there's the T1, the token group account. It has the 6 to 90, that's the mint. So what is this then, if that's not the mint? Oh yeah, the other mint. Of course, the other mint. Both start with 6 because both of them I made start with a capital T in base 58. So obviously, yes, both is the mint, but like the one is the mint of the token group and the one is the mint of the token that we're currently talking about, that is the member. So one is the T1 and one is the TGC. So this is the TGC that is stored here. Wait. No, it's not. This is the mint itself that is stored here. So in the extension 22, we just store the authority for the token member pointer, like group member pointer, the authority, and then the token itself. So this is the T address. And then in the extension 23, which is now actually the pointer, this was just the we are a member, and this now is the actual pointer, which says this is our mint again. So first comes our mint, and then this is where we're pointing to. Yeah. And then the one, probably it's the index, because a collection or a group in this terminology, the individual tokens there, they have an order. So probably that's what we're storing here, because it's the first one. Would make sense. And then if we check the TGC once again, then we see that also here it changed to now it's 1. Like that's the current members. And member number 1, starting counting at 1 though, is this. Because you want to have the difference between it's not initialized, all zeros, to it's an actual member and it's member number 1. That's probably why they start counting at 1 in this case. And then there will be a member. It's possible that there is a member with the same number as the max group size. So I can do another member and then they're both 2. I'll just do that just to demonstrate. I'm not going to make a, or am I going to make? No, I'm not going to make a separate address for it. I'm just going to create another token, and conveniently the address is 2BB. So that's member number 2. We shall add that to our group. So this should also be part of this group. Boom, that will do. And Solana account of this will now tell me that this is member number 2. And if I would want to add yet another member, so let's create another token, and I try to add it to the same group, then this should fail. Yep, because custom error this unknown. Great, the error handling could be a bit nicer, but then again, we know what the error is. The error is that the length of our group size has been reached. We can't have more than this, and we already have this many, so that's why it fails. Yeah, that's that. I do want to, I'm pretty sure that this is what it is, because here it's token 2, so that makes sense. But I do want to see it in source code as well now. I would like to see the state of the token group member. That's the group member pointer, and that thing as a group member pointer, which just has the authority and the member address. Does that make sense? Yes. So first the member pointer that just holds the authority and the member address itself. So that's usually pointing to itself. And then the token group member, token group member pointer. Where would that be? It's also part of the token group. Token group has what we saw earlier with the size and the max size. And then token group member also belongs in here. So that's also in SBL token group interface member, the mint, the group, and the member number. As I said, they are numbered. They have an order. Yes. Okay, so that's one extension that kind of belongs together. So this and this kind of belongs together. It's basically the same extension because there is no group member without a token group. And apparently for the pointers, it's separate extensions. Like the metadata pointer is separate to the metadata. We then also have the group pointer and the group member pointer being separate extensions here in the source code, whereas those are basically the same. They kind of belong together the same way that the pausable and the pausable account belong together. That's part of the pausable extensions, but one is an extension on the mint and the other one is an extension on the account. Whereas for those, this and this, it's both on the mint. But whatever, we saw it in the source code, but lost it again. Here, the state. We saw the state for the token group and the token group member, which is always the most interesting part of the source code, looking at the state structs. And we saw it on the accounts, on actual accounts with examples. And we know how it's done with a CLI. First create token with enable member or enable group respectively, and then initialize group or initialize member respectively. Yeah, initialize member. That's how it's done with a CLI, but we're devs. We want to do it in code because we haven't really looked at the actual instructions that I need to send in order to do this. So that's what we'll do now. Figuring out how we can create a group and then a group member with the kit, Solana kit. And then we will need Solana program token 2022 or token, nope, that's not token dash 2022. Yeah, that looks better. Those will probably have the right instructions in there. I hope that those extensions have been added to the kit. Let's see. We will have our authority. We'll go to DevNet. Let's start with creating a group. We'll have our authority, this thing. So that's just my classic simulate and send the transaction script. And now as for instructions, we said those we're gonna get from the Solana program token 2022. And here, hopefully we have a get initialize token group instruction. There we go. So when we do it, obviously we can do it all in the same transaction. We don't need two transactions to initialize the mint and add the token group info, right? We can do that in one. The CLI just doesn't, because that would make it complicated in terms of instructions and in terms of command line arguments. But we can do it all in once, obviously. So, I mean, we can start by creating a simple token just to get that out of the way. Let's say my mint is generate keeper signer. Ooh, we have a sync. Oh, I want a keeper signer. That's not sync anymore. Okay. And then we should also have a get initialize mint. There's a 1 and a 2, so I would guess I need the second one. Probably both work, but it might be deprecated. Decimals. I can already be like, we have 1 decimal because eventually we will work with NFTs, and most likely, like the most likely use case for groups is NFTs, where there are several tokens that are distinct tokens. So it's different types, but they all still somehow belong together. That's why we put them in a group, but have them be separate tokens. So they're non-fungible. They're not exchangeable for another token of the same kind. And then usually it makes most sense if those are tokens where there just exists one, and then it makes most sense to set the decimals for that token to 1 and only mint 1. Then you can't split it. So let's do that already. Let's set decimals to 1. Mint will be my mint address, and my mint authority shall be my authority. There. Okay, no, you just need the address. Okay, so the initialize mint doesn't take any authority, like doesn't require signers, because it expects that the account already exists. So we will need to make the account exist first. So we will need to also get Solana program system such that we can, from Solana program system, get a create account instruction, which we need to do before get create account instruction. And this thing takes the usual, the account we want to create, which is the mint, the account paying for that, which is the authority, which also needs to sign. Okay, the program address, that will be token 2022 program address. That's the owning program. And then Lamberts and space. Well, Lamberts depends on the space. So let's calculate the space through the extensions. There is a get mint size for extensions, and extensions is an array of extensions. I'm not going to do a close authority, like the closable extension for this one. I just had that in case I make a mistake and I want to recycle my key pair, but here I do new ones every time anyway. So let's just use the extension, by now I know how I can create an extension. That was already very difficult to figure out, but it's just the function extension. And the kind is group member pointer and also extension group config, token group, that's it. So this one holds the config and this one points to itself in our case. And why you complain? Group member pointer is not assignable to parameter possible account. Yeah, of course not, because it's a different extension. What? What's your problem here? What do you need exactly, Mr. Extension? Oh, you need... Wait. No. The kind, which is just a string. One argument, the kind, and you even suggest that. And what's your problem with this? Never. This doesn't work. What? But that's how that worked, though, last time I did it. That's how I think I need to do this. Let's just return here for a second. Could I run this? Could not read property of undefined length. So where do we fail here? Token groups, address. Where are we failing here? I feel like we're failing already somewhere else. No, that works. Doesn't work. Oh, maybe if I have a kind, then I need to give you more. Ah, yeah, because if we have kind group pointer, then you also want data for that group pointer. Ah, yeah, that makes sense. Sorry. Okay, forgot that. Okay, what do you want then? For the group member pointer, you want the group member point. Ah, this is not helpful. Is this helpful? Is this helpful? Is this helpful? You want the data, which is a extension arts group pointer, which is, here it says it, group pointer authority. So authority and group address. Could that be? Authority. I'm not sure how I need to provide this. No, hold on. It gives me the extension with this. But what is this? It's a discriminated union variant context of extension arcs of this kind. Yeah, but like more info, please. Group member pointer. I mean, if you're a beginner TypeScript dev and you're completely overwhelmed by what the hell is going on here, then this is understandable, because not even as a non-beginner TypeScript dev who has been doing this for a few years now is this self-explanatory. For extension arcs for this where do you get them from then? And how do you properly provide them that data? This would be something like this, right? Here the data is yet again an object with the authority of probably an address of whatever. Well, or I just use my authority, my real authority here, that address. And then what else did it need? It doesn't tell me. The group mint authority and group address. If I just call it that, it's fine. Yeah, but you gotta know those. Like, this is so annoying because it doesn't suggest the right names, and then it's just like guessing. But anyway, no, it's not guessing, it's reading and then hoping. But whatever. Okay, it's just DevX could be improved on this, I do admit. But we still want to work with a kit because, I mean, at least the functionality is there. Okay, so that's extension 1. Extension number 2 will be a token group. And guess what? That will need a discriminated shalalala of whatever with token group, which gives me that. So I probably need to put, let me guess, the update authority and the mint and the size and the max size. And probably I can somehow get that properly, but I'm just gonna hard code it like this. Update authority. I'm just gonna write them because I still see it. Mint, size, and max size. But that's weird. Why would I need to give the size? I probably don't need to give that when I mean, it's not like I'm initializing the extension. I would like to say like default. Just give me that like I'm just using this to get the right mint size. I don't need to have the correct data in here. I can just have placeholder values for all that stuff. It doesn't really matter, but I'm gonna fill it out correctly anyway. Mint shall be the mint address. Size shall be 0. Max size shall be 2, like we had it in our example, and then it works. The reason why they need it here is that an extension could potentially, depending on what values I give here, have different sizes. For instance, if they would have used a normal option for the authority address, then, you know, if it would be none, it would be smaller, but overall it would be bigger. But they chose to have static length, which makes sense. It's just way easier to work with. But that's why it doesn't matter what info I put in here. I'm gonna put the right info, but the info for that extension is just being used for getting the size of the mint. And since both of those extensions have constant size, it doesn't really matter what I put here, so it's a bit annoying that I need to put stuff at all. Just saying. Improvement suggestion for the kit. Let me allow to get a default empty extension just with a name, because this is otherwise a pain. Anyway, moving on. Let's not complain. Now that works. We can go back to building our instruction, where we can now finally give the space correctly, which is the space that we just calculated, and we can give the lamperts correctly by saying, RPC, can you please get me the minimum balance for rent exemption for that amount of space, please. And then it will just do that, and then I will be fine. Number is not a big int. Oh, you're not a big int. There, it's a big int now. Okay, and with that, we create the account and we initialize the mint. Just a regular mint. Well, not so regular anymore because we use 2 extensions. But let's just see if that works. Let's just see if we could run that, because we can't. Because invalid account data, I mean, the system program worked so far. And invalid account data, maybe it wants something to be initialized first before it lets me do that. Well, then how about screw this? I'm not gonna use any extensions for now. Would that work then? That would work. Okay, good. So we just know that we haven't initialized them properly. And that would, just to double check, that would just be a regular, I'm creating a mint. So this would be my mint, where we first do a system program, create account, 82 bytes, and then initialize the mint. So Solana account, this is now a mint, like a regular mint without any extensions. If we wanted to have extensions, and that's funny, I just added an empty thing here, then it suddenly doesn't work anymore, because we have invalid account data for instruction. Because, why is that? You probably need something else initialized first. And if you don't know anymore, a really good way to figure out what you need to do is try to do the same thing with another tool that knows how it's done. For instance, the CLI. SBL token, create a token with the program 2022. I just want to see how that's done. Oh, and can I have, so far, I think, let's check, that it will probably also do the same thing that I just did without extensions, which would make most sense. Yep, also 82 bytes, but I guess I will need to add an extension such that it uses extensions. What's a simple one? Why not use enable group? Use the one that we are interested in, and then actually check that transaction. Shooby-dooby-doo. So again, I create account, but this time with 200 something bytes. Token program, unknown instruction. Great. And then initialize mint. And it's initialize mint, not initialize mint 2. Although I'm not sure where the difference is. Can probably use both. And the unknown instruction does what? It initializes the group pointer. Yeah, so we will need to do this. I just thought I can initialize it with extensions without initializing an extension first, but apparently not. So my guess is now that this will just never work, like empty extensions will just never work. But if I initialize it with the group pointer, and might as well already use the token group thing as well, because I don't need to initialize it already, but the group pointer I need to initialize. Hold on, but if I only have token group, obviously it will also not work. But does it give me an error here? Does that give me a... No, also just invalid data. No, never mind. Let's add both of them already and do the thing that it expects. So before we initialize mint, because the initialize mint is the, okay, it's an official token now, we need to prepare it. We need to prepare the mint account with all the extensions. And that we do with get initialize token group pointers thingy extension. What's it actually called? Get initialize group pointer instruction there. And what does that need? Just the authority, the group, and the mint, which all of that I have. And the group address will be again my mint address, because the group pointer points to itself. That's what we're doing. Same as with the metadata pointer pointing to the same mint, we are pointing the group pointer to ourselves because we will hold the token group information as well. Okay, initialize group pointer, mint then probably just needs the mint address, and the authority probably also just the authority address. Okay, fine. But then hopefully we should be able to create this group token. No. Nope, still nope. Invalid data. What are we still doing wrong? We're using the mint2 instruction. Let's use the mint. Something else if we just use the mint instruction? Does that take different data? Would it work with this one? Of course not, because let me guess, it does pretty much the same. That could be also a deep dive. What's the difference between mint and mint2? And what's the difference between initialize account v2 and initialize v3? Because there are 3 versions. And they have to keep it all for backward compatibility. It's stupid. Anyway, this stuff worked though. I can initialize it. The group pointer instruction, I can initialize it. And then initialize mint will give me invalid account data. Maybe because it's at that point still too big, because I'm also already expecting to have the token group extension. Okay, fine, let's remove that for a sec and see if that will fix anything. That will indeed fix something. Awesome. Okay, cool. So then I can initialize a mint like that. Amazing. I love that. Look at that. Look at that. Ha. We create the account, we initialize the group pointer, and we initialize the mint. And then the mint, if we check the account, will have that extension 2020 with the authority and that mint. Ha! But it still doesn't have a token group now, so I will need to add that extension, which I can do in a separate transaction like the CLI does. Let's do that first. So our group will now use this as the mint. It doesn't need to sign for this anymore, so I don't need the signer. Also, I don't have the signer anymore. I just used it and then threw it away. So here, if I now need the right space, I will need to add both extensions. And then I will probably need to add lamperts and space and stuff. Or maybe the extension does it itself. I'm not sure. We will see. So my guess would be I don't need to do a system program thing anymore because the token program already owns the account. I don't need to initialize the group pointer instruction anymore, but I will need to initialize the token group. Initialize token group instruction. What you need? The group, which is probably the mint. The max size, which I'm gonna say is 2. The mint, which is again the mint authority, which is my authority. The update authority, which is also my authority, conveniently. The update authority is the update authority for the token group. So that's the address that will allow then to add members. So it can be a different one, right? We can use a different authority. I just make it easy for myself and use always the same one. But then it might be confusing what that actually is now. It's not a thing that needs to sign. The update authority here doesn't need to sign. I could set anything. But if I set it to something where I can't sign with, then I can't add members. So I'm just going to recycle my own address. And I trust you that you could put something else if you wanted that. It would be safer as well. Like if you split the authorities, always a good idea, like for production use cases, because then if one authority gets compromised for whatever reason, it's just the token group authority, like that it can just add members. It can't change the group. But yeah, for our testing, it's fine to use the same for everything. And that maybe is everything that I need. Let's test it. Let's test if the token program is smart enough to let me initialize this with just this one instruction. No, yes, this gives me success, but I still get an error from my RPC. Transaction simulation failed. Context account index 1, error code this. The logs give me success, but maybe that means it's a runtime error, like it's a transaction error. It's probably something like your account doesn't have enough rent for rent exemption. That's why we can't let you do this, even though the instructions would succeed. But that makes sense because we don't put enough lamperts on there, because when we created the group, we created it only with this one extension and not with 2. So we will need to add additional lamperts. Can I prove that's the error code? Account index 1. Yeah, it's an error code about an account, and that's the first one. And I'm pretty sure that it's that. Like, I'm so sure that I'm actually not even gonna check that Doesn't give me the name for the error code though. Ah, here. Insufficient funds for rent. Haha. Yeah, I told you. When I simulate it, I get the actual error as well. Ah, cool. Okay, yeah, then we know the right space. We know how to get minimum balance for rent exemption. So required Lamperts is this. And the Lamperts we have, we could guess that. But therefore, we would need to query that account first. Then let's do it the clean way. Current Lamperts get account info for the Mint account. And really, I'm just interested in the Lamperts, which it will totally have, because that will totally work. And I guess I can do that even afterwards, because the check for the minimum balance is only at transaction level. So if afterwards I put on enough rent to save that account, I can even initialize it further. So I'm gonna transfer, no, it's called get transfer, yeah, from the system program. And we are gonna transfer the required Lamperts minus the current Lamperts to the Mint account from my authority account. And I'm also signing. And this is Lamperts or undefined. Well, then let's pretend there's 0 on there if it's nothing. Lamperts. Oh, this is just annoying. Can you just automatically parse begins to numbers? Do I always need to write begin? This just makes this so annoying to work with. I'm sorry. Another improvement suggestion for the kid. Just saying allow both number or begin. Thank you. But like that, it should save our account from being garbage collected / since it's under minimum rent, it was just stop the transaction from failing. Let's see. Can we initialize the group? No, we still can't. This time with the error, JSON send is not a valid request object. Damn it. I am not doing this right. Once again, because that stupid account has more than 128 bytes. Can you, per default, set the encoding to base 64? Because that's just so annoying. And then somebody who doesn't know what that means will be completely lost and not know why they need to add this. Just make it default base 64, please. That would make it so much easier. But then we can hopefully, if we get the correct Lamperts here, yes, then look, we can do this. It has success, and then we put enough Lamperts to sustain our rent. And that way we can actually initialize this token group. And then this token will also have the token group extension here. Nice. Currently 0 and maximum 2. Funny. Okay, that's how you do it. The same way as the CLI does. Maybe let's also do it differently, because why would you need 2 transactions for that? That should work in 1. Let's do a create and initialize by doing basically both. And I could do it like that. I'm just gonna add all the things. And just to prove that would work, just gotta change those things again. And this calculation I can now also do better. I'm just gonna once do space 1 and use space 1 here. And then space 2 will have both extensions, and then space will be space 1. Let's just do Lamperts 1, Lamperts 2, and put... This is ugly, I will change it, don't worry. I'm just gonna first make it work and then improve it. So Lamperts 2 minus what we already put in Lamperts 1. This is still not working. Okay, so basically now we're doing the exact same things as before, just all in one transaction. That should hopefully also work. Yep, bye-bye. But admittedly, it's a bit ugly like this. We first create the account, then initialize that, fair enough. Then do the initialize group, and then still top up. Can't we just have the correct account size from the beginning? I ask, and the answer is, I don't know. I don't know how the token program actually operates. Hold on, Lamperts. We're not even talking about space, we're talking about Lamperts. So obviously, I can't just have more Lamperts on here and here say, use the Lamperts that you need for both and not use the Lamperts 1 at all and just call this required rent for the entire account also for later. But this one I need to compute with both extensions. And the first one, the space that I initialize it with, I need to calculate with just one extension. Gotta know that. And then you can remove that instruction because we don't need that. And then it should also work. And that's the clean way to do this. All in one transaction. It would look like this. And then it's just those 4 instructions. Isn't that nice? Okay, Could we theoretically do this initialize token group instruction before we initialize the mint? That's one thing that I want to try. We do this first and then also set the space to space 2 from the very beginning. Would that work as well? That we initialize both already? That could also work. The reason why it doesn't work with space 2 is because something doesn't work out with the account data, there's too much data there or whatever. So I guess that's why this does not work now, invalid account data. But if I add that instruction, maybe that would work. I imagine that would work. No, it doesn't work. Instruction requires an initialized account. Okay. The initialized group requires the account to be initialized. Okay. Nope, it does not work. We need to, in fact, first do the initialize mint and then initialize the token group. Okay, now we also know that. Glad that we checked it. But that's already basically it, right? The members will work the exact same. And since you want to see it, I'm gonna quickly do it as well. It's just a writing exercise, really. So I can create and initialize, now that I know how it's done, member. And it's basically the same thing, different extensions, namely the group member pointer and the, what's it called, token group member. And they will have different thingies here that I don't know what they are. What was for the group member pointer? I think it was called mint. No? Okay, what is it called? Group member pointer, authority and member address. Okay, member address. Gotta know that. And the token group member, token group member, mint, group, mint and group. Again, I do think that there is a nicer way to do this. I don't know, but it's probably not what I'm supposed to do. I'm probably just using the kit wrong, but it works. So that's why I'm doing it for now. Because also I don't know how it's done properly. But if you do, please tell me. Token group member, mint, group. Oh, because group is... Oh, and we're missing the member number. Okay. And again, I could put anything here. I could put over 9,000 here. It really doesn't matter what I put here because that will not be used except for calculating the space. That's why this is a bit pointless, but whatever. That's why I can set the group to authority address. It doesn't matter. This is wrong, but it doesn't matter. I could even set it to the goddamn freaking system program and nobody would give a single F. So therefore, I'm gonna do that just to screw with whoever reads my code. We will probably need both of the spaces again. First create it with space 1 and then calculate the required rent for space 2 though, because first we just initialize the member pointer and then we add the member. And the instructions will be the following. We create an account for that mint that we created a new signer for, just a random address. We pay for it, assign it to a token program, give the first space, so just the first extension, and already add the required rent for the larger account. Then we're going to do something else. We initialize a group pointer. Wait, no, not initialize group pointer. What do we want to do? Group member pointer. Group member pointer instruction. There we go. Which needs authority, member address and mint. Authority be my authority. Member be the mint. And mint be, hold on, am I doing that wrong? Mint be the mint. Wait. The group member pointer. Oh, the mint is then the group. You could have named that better. The mint is probably the group. So gonna call it my group. And we're just gonna use one of the groups that we just created earlier. How about this one? The 3 up. 3 up. And then here for the mint, I shall put the group. And then I initialize the mint. And then I initialize the token group member. So initialize token group member instruction, which takes the group, I have that, the group update authority, which happens to be my authority, the member, which is my mint, the member mint, which is my mint, and the member mint authority, which is also my authority. Okay, and the authority always needs to sign. That's why I need to provide it as a signer. And if you're now confused, what the hell are all of those things? Then congratulations, me too. Because what the hell? Let's go through it slowly. The group, fairly self-explanatory because, I mean, that's where we point to, right? The group is the thing that our group member pointer points to. We could have already named that better, admittedly, but it's fine. That's fairly straightforward. Also, the group update authority, fairly straightforward. That's what's inside the group. So that token that we created earlier here, this one, it has an extension, namely token group, which has an update authority, and that's what we need to provide. So that's also fairly straightforward, because without that authority we can't change the current size, and we need to change the current size. That's there to protect anyone from just adding tokens to your group. Obviously you don't want that. You want to be able to say that all of the tokens that are in this group are actually belonging to that group because I signed for it. So yeah, that's that authority. Then the member and the member mint is where it gets confusing. The member, I think this is my current mint that I'm currently setting this for. That's who I'm setting it for, I think. So that's what I'm writing into this token group member extension. That's what I'm writing there. And what I'm writing there is the member mint. And this is where it gets a bit boom, because apparently I could set the member of a different mint in my mint, even though I'm a completely different mint, and assign it to a group. But for now, I'm setting myself. So I'm setting my mint as this member mint as well. And then the member mint authority, that's fairly straightforward again. That's the authority that we established right up here. Because again, this could come from a different token, or this could live on a different mint, or I could have set a different authority address here, setting the group member pointer. You can play with that, right? Yeah, there might be nice use cases where that's a PDA and then that moves the group around or whatever. So it just moves the pointer. And who is allowed to move the pointer? Well, this authority. So I'm pretty sure that this authority is what I need to put here. But I'm only pretty sure, so we will test that. But with this, it's fairly certainly gonna work. I'm gonna create and initialize this, and obviously it's not gonna work fairly sure from my ass. What did I mess up again? We fail account or token already in use for group member pointer instruction. Group member pointer initialize account or token already in use. Well, that's great. What am I doing here? Am I getting this wrong? Is the mint here the mint that I initialize it for? Oh yeah, that makes sense. Hold on. Yeah. That makes way more sense. Hold on. Because otherwise, how would this guy know that I'm initializing it for that mint? Because it's an instruction to the token program. It doesn't have the context of anything, what mint we are talking about. So obviously the mint itself is actually the mint we are initializing this group member pointer for, and the member address, that's the member that we are initializing it for. So that's what we write in there. So on this account, we write this address for the group member pointer, but the pointer, this is so confusing. Hold on, am I getting this the wrong way around? No, it's fine, because, so I take it back, it's the naming is okay, it's just still confusing, and the authority will be the authority for that member, like changing that pointer. So basically what we're doing here, this is way more complicated than I thought. What we're doing here is, first we're saying, hey, this token mint has a pointer for a token mint to a group, but we're not setting the pointer yet. We're just saying there is one, and this is the guy that is allowed to update it. Then we're setting what mint this is for, and that's the same mint. That's what we read in the source code, the group member pointer. The mint contains a pointer to another account or the same account. Where did I read that for security reasons? In the source code where we store the mint. The token group member. So in the member, but also in the token group, it says the associated mint used to counter spoofing to be sure that the group belongs to the particular mint. And I still don't get it. We store the mint to prove that a group belongs to a particular mint. So anyway, when we initialize the group member pointer, we say who is allowed to change the pointer. But the confusing thing is the token group member. This is the actual pointer though. Wait, no, that's the group. That's what confuses me. So when I think of the pointer, I was thinking of we point from the mint, so from the member to the group. That's the pointer. But no, that's just the token group member extension. That is a pointer as well. A token group member just means we're pointing from member to group. But what we're initializing here, the group member pointer, which holds the authority and the member address, that basically just points for the mint to where that thing lives. So the group member pointer, the authority of that allows you to change the member address, right? So because you could set that to a different mint. Usually you would set it to the same mint, member address then being the same mint, but I can have this thing, the token group member, live on a different mint. And therefore also this authority that we're setting here is the one that can change the member address. But for now, we're setting the member address to our own mint. Because in our own mint, we will then also initialize this token group member, which then holds the information for the actual group. Okay, now it's slowly starting to make sense. Okay, so basically it's all pointers. This one points to this thing, which points to the mint that is the group, which has a pointer there, which points to another mint or the same mint that then has the actual group information. Poof! But okay, sure, let's do that. So we initialize it here with that mint. That authority can change that address and point it somewhere else, but we point it to the same mint as we're initializing it for. Then we initialize the actual mint. It's just a 1 decimal token. And then we also initialize the token group member to actually have the member point to a group. And to change that member, like to change the group, basically, there's yet another authority that I'm setting. Wait, no, that's not this one. That's this one, the group member authority. Wait. No. So this thing. All right, I understand. To create this thing, you need to sign with the mint authority of this mint that I'm doing this for. Wait, no, it's not the member. It's the member mint. Man, I'm not sure which one. Oh, this is so confusing. But anyway, the token that I'm writing on, right? The mint on which I am adding this extension, this guy's mint authority needs to sign and thereby is able to initialize that. And then once it's initialized, I don't think there is an authority for that anymore, because those two authorities here, the one here, that's the group authority. So that's the one that needs to sign because we changed the group that we initialized on the other mint. And this is the one, I think, because it also needs to sign, this is the one that we created up here. So also that authority needs to sign. So maybe that authority, I'm pretty sure that it could change that address, the member address, but I guess it will, but it seems like this same authority also needs to sign to then change, or is it, oh man, my brain is already smoking. This is so confusing. But yeah, so basically that authority is the authority up there. And wow, this video is getting long. I did not expect that to get that difficult here. But yeah, like this, at least it should work. Let's test that it's actually working this time and then analyze it further. So yeah, this is working. We can create an account, initialize the group member pointer, initialize the mint, and then initialize the token group member all in one transaction for this mint. Let's look at it here. It has the group member pointer and the token group member, and we see its member number 1. See it here, member number 1. And that's the group and that's the mint. See that this token group member doesn't actually have an authority. That's just the information for which mint and which group. This is the how manyth member. So this is just where the state is. And in order to change that, I guess you need both the group and the member authorities. So the group member pointer, this authority, which can change that pointer, and the token group update authority, I guess you will need as well to make any changes, because there also changes the size. If I refresh here, we go from 0 to 1. Okay, wow. But it's starting to make sense. It's starting to come together. Let's just do some quick checks. If I had a different authority, let's say I have another authority, which in this case is just a key pair, and when I initialize the group member pointer, I don't set it to my authority but the other authority, then this should not work anymore because we don't have enough. What? Okay, I was wrong. I gladly admit that I was wrong. I created it. I initialize the group member pointer. That's the mint, and the authority is a completely different authority. And then when I initialize the token group member for this member, the member. Oh, authority! It says mint authority. I just didn't get it. Mint authority. Of course. Sorry, having a moment here. The member, that's the member, and the member mint authority is the one that needs to sign. Mint authority, not member mint authority. We're not setting an authority for the member mint. That's why this name was so confusing to me. No, it's the member, which is this, the member mint, which is the account, and then the member mint authority of that mint. So of that mint, the mint authority needs to sign. Yeah, that makes sense. And so I guess this authority over the member address, well, is then just used to change that address, I guess, if you ever want to. But that, I guess, is then a bit confusing because then you can point somewhere else and you're still member, the extension is still member of that group, even though no group member points to that anymore. But man, we're getting in the details here where I'm like, maybe it requires another deep dive video just on the nuances of that. Because man, my throat hurts. I gotta stop talking after a while. Hey, it's getting rough on my throat here. But I'm glad that we checked that. Okay, so this is the mint authority that needs to sign. Yes, so that makes so much sense. I mean, I said it earlier that the mint authority needs to sign. And then literally the mint authority is here and I provide the mint authority. So obviously, yeah, okay. So to initialize the group member, we need the mint authority. Member mint authority. And if the member mint would be a different mint, then we would need that mint's mint authority. But since we're always using just the same mint, it's this mint's mint authority. Oh, wow. Okay. And the group authority, I think that makes sense. That's the authority in the group. Not in the group pointer, but the group update authority. That I don't even test because they're fairly certain that's the case. Okay, are there any other loose ends that I need to tie up before closing here? I have a semi-open thing with this to counter spoofing to be sure that member belongs to a particular mint. Because you can set anything as your member, like you can point anywhere to any mint in order to be sure that in there is also the actual mint that we set it for. We need to write the mint into there. Okay, I'm starting to get it, but that's a use case that is, I would say, fairly unlikely, and I don't want to blow up this video, noticing how long it already got again. You know what? I'm gonna make a separate video on fun things with token groups that nobody will ever use, but are fun to do anyway. Like having the member be in a different mint than the mint itself. Also, maybe some more use cases about this. I talked enough now, I think, that I'm happy to close it here. But it's fun. This is really fun that we have this extension. And I'm gonna close with maybe repeating what we kind of already said, that this group extension, or the 4 extensions that make up the token groups, with all the pointers and which make it a bit complicated, but therefore also versatile, and you can do different things and have different authorities that are responsible for the individual thing. So it's very modular, and that makes it nice, but it also makes it confusing to work with and use up a bit more space, like state. But that's okay. Like, it's a very specific use case. And yeah, the main use case is, I would say, collections, what we know from Metaplex and then other protocols where you have tokens that belong together but are separate tokens, non-fungible. And you still want them to be part of one thing. And Token 2022 calls that the group. I would call it a collection because that's the word I got used to from NFT collections. You can do that natively with Token 2022. You don't need any other programs for that. It is admittedly a bit complicated, but it's also clean and it gives you a lot of things to play with. And I just decided I will make another video on this because there's so much more to explore. But this was still a good deep dive. We looked at the accounts. We looked at how it's done with the Web3.js. We did go through source code. I'm happy with that. I can say we did enough today. I don't want to overwhelm you with useless information that you don't need anyway, but might still be fun to have. So for that, there shall be a future video, and you can watch all my other videos on token extensions. Give this one a like, subscribe if you haven't, and I will see you in the next one. And I shall now rest my voice, cause goddamn have I been screaming a lot. Okay, bye! Would I have imagined to take that long for that video? Absolutely not. Would I have imagined that I want to make another video about this? Absolutely not. Will I though? Oh yeah, cause now I got motivated.